Hello everyone and welcome. In today's video we are going to talk about Python operations, which are the operations used between values or variables in various ways and conditions. Mainly we are going to talk about arithmetic, bitwise, comparison, logical, identity and inclusion operations. First, let's start with the arithmetic operations. Here, let me declare two variables so we could use them. Let's say x equals to 5 and y equals to 2. Obviously, we have addition, simply x plus y, subtraction, x minus y, multiplication, x multiplied by y, and division, x divided by y. Right now I'm in Jupyter Notebook, so I could print the values only with the name of the variable like this. Here, the results, or we could use the print function and print our values like this. The second type of operations, we have the bitwise operations, and this type of operations will use the bits level in their work. So when we declare, for example, x equals to 2 and y equals to, let's say, 6, this type of operations will use the bits level. So x will be 0, 0, 10 and 6 will be 0, 1, 0, 1. I think that's, no, it's like this. Also, I don't think this type of operations are very common. It's like they only work under certain conditions. Let's say operation x and y. This AND operation will work like this. Let me zoom in. So we have x, this is the representation, and y, this is the representation. The result, result is like this. 0 and 0 will give us 0. 1 and 1 will give us 1. 0 and 1 will give us 0. 0 and 0 will give us 0. And this is 2. Sorry, this is 2. Let's print the result and check if I'm correct. Exactly, it's 2. When we have 2 bits, 0, it will give us 0. When we have 1 and 1, it will give us 1. When we have 0 and 1, it will give us 0. So simply, when it will give us the same bit when it repeats 2 times, and 0 when the 2 bits are different. The second type, we have OR operation, equals x or y, result equals 0, sorry, here, or 0 or 0, it is 0, 1 or 1, 1, 0 or 1, 1, and 0 or 0 is 0, and this is 6 in binary. Let's print the result. It is 6. How OR works? Simply, when we have 2 zeros, the result is 0. When we have 2 ones, the result is 1. And the other cases, only the appearance of the number 1 is sufficient, so the result will be 1. For the third type of the operations, we have the left shift, x, and we shift it to the left, sorry, to the left by y. Or let's inverse it, x, y. This is like we shift the number 6 by 2 bits to the left. How we shift it to the left? We simply add zeros in the very right side. So this is our 6, and let's shift it by 2 positions. The very first position, it will become like this. So we shift these 2 to this place here, and then this 0 is this 1, and we add another 0. Then to reach the number 2, meaning the second shift, it will become simply like this. Here the 1, here this is the 1, 0, and This is the number. So let's print it here to check if we are correct or not. So this number in binary is the same as 24. Left shift exists, so right shift also exists. We just flip this operator. When we shift to the right, we will add zeros in the left part, in the very left part. So we have this. Let's add a 0 and remove 1 from here. Then, because our x is 2, so we will shift 2 times. We will add a 0 and remove the last one. And this number is obviously 1. In binary, let's print the result. And this number is 1. For the next operator, we have the not operator. It will work only with one variable. We will use our y variable here, and to say not, it's this operation, and we say y. Before I will print this result, let's use the binary. So the result of not, we will simply flip the bits. When we have 0, it will be 1, and where we have 1, it will be 0. Let's print the result, and it is -7. For the XOR operator, we have the inverse of the OR, of how OR works. When we have 2 zeros, it will give us a 0, and when we have 2 ones, it will give us a 1. For the XOR, when we have the same number, it will give us 0, and when we have a different bits, it will give us 1. So 2 zeros are the same number, it will give us 0. 1 and 1, same, 0. 0 and 1, not the same, it will give us a 1. 0, 0, the same, it will give us 0. And this is 5. In binary, let's print the result. XOR operator. It's 4, sorry. The third type of operations, we have the comparison operations. The operators that are included in this category will give us a binary result, meaning it will give us true or false. Operations like superior or inferior, equals, not equals, superior or equals, inferior or equals. X equals 2, y equals 1. Let us print x is superior than y. This will give us true. Let's print x lower than y, and this is false, of course. Let's print x equals to y, which is not true, so this will give us false. Wait, sorry. The equals is double equal. This will give us false. When we want to print x is not equal to y, which is true, of course, 2 does not equal 1. Let's print also x inferior or equals to y. This is, of course, not true. If we change the y to 2, this will give us true. Exactly. And this will give us false, because 2 is not superior than 2, which is our case here. And the same for the x, the x superior or equal to y. Let's change x to 1, and this will give us false. For the logical operations, we have to use an operator between two statements. So let's declare statement 1. Let's say, for example, 5 is bigger than 2, which is true. And statement 2, 7 does not equal to 7, which is of course false. The first logical operator, we have the AND operator. So let's simply print state 1 and state 2, and this is true and false. True and false will give us simply false. Let's print it. Exactly. We have the OR, true or false is true, always true, because the appearance of only one true is sufficient to to give us the true result. And for the last operator here, we have the not operator. The not simply, it will reverse the result. So when we have this is true, let's put a not here. So state 1 or state 2, this will give us true, but it is inside a not operator, and this will flip the result. So when it's true, it will be false, and when it's false, it will be true. So the not true or false, which this evaluates to true, the not becomes false. So let's print the last operator, and it is false. I will cover these two types in later videos, because we will have to introduce arrays and lists. So we reached the end of our video. I hope it was simple explanations, easy to understand, and so yeah, see you in the next video.